Hey guys, it's Mr. Ross. You're probably wondering why I'm wearing this ugly Christmas sweater. If you're watching this in the future, it's because it's ugly Christmas sweater day. But also, it's very appropriate because we're going to talk about glaciers, and glaciers have to do with cold areas, so we think about Santa Claus and all that kind of stuff. Just take it for what it's worth. All right. We've been talking recently about constructive and destructive geologic processes. After that, we started getting more specifically into weathering, erosion, and deposition. And we gave a couple of examples of some really powerful erosional agents, and they also will create some deposition. They'll do some other stuff with weathering as well. So, first one we're going to talk about here is glaciers. So if you guys take a look here, we actually have 3 glaciers in this. This whole long thing right here is a glacier. Here's a glacier. Here's another glacier. And if you look, this glacier is actually a combination between 2 glaciers if you go farther back enough. Okay, so there's a glacier. There's another glacier. They kind of come together. Now these look really dirty, and no, that's not pollution. This is not going to be a lesson in making sure that we clean the environment up, but we should, just so you guys know. That's going to be all of the sediments and rocks and everything that the glaciers have picked up over some time, but we'll get into that in just a moment. So, what is a glacier? It's just a big moving mass of ice. We have 2 main types of glaciers. The first one is going to be an alpine glacier. When you hear the word alpine, you can think of mountains. So these are the ones that form up on top of mountains. They move downhill. The force that is moving them downhill is going to be gravity. We also have continental glaciers. Continental glaciers are extremely large, and they will move in multiple different directions. So they also move downhill, but they're going to cover a much bigger area. The continental glaciers that we have right now are typically up in northern Canada. We have a big one in Greenland, and we also have one in the Antarctic. So they can move up to 30 meters a day. That would be called a surge. 30 meters doesn't sound like a lot, but when you have a huge amount of ice, it takes a lot of energy and force to kind of get that thing moving. But most glaciers, they'll only move about 20 to 30 centimeters a day, or sometimes they don't even move at all. Okay? Glaciers form because of snow accumulating on top of more and more snow, and that snow kind of compacts down due to gravity. It forms ice. So basically, the glacier is a huge sheet of ice that will move. It slides downhill due to gravity, and when it's sliding downhill, it will pick up rock. It'll carve out the rock. We're going to see in a second how it will do some weathering and erosion stuff. But glaciers also melt, and they will crack, and there's all sorts of different things that will happen with the glacier. But if you look at this picture, snow is going to kind of fall down here. After a while, the snow loses its crispness. It's not quite as snowflakey. It's not as crystally. And we get this thing called granular snow. Granular snow turns into firn and then glacier ice. And this is all happening with compaction over time. So we also have 2 zones of the glacier. If you look a little bit farther up, and this is an alpine glacier. Farther up, we have this area called the area of accumulation. This is where we are accumulating snow faster, or glacier ice, sorry. We're accumulating it faster than it can actually just, evaporate or melt or whatever. Down here, and this is what we were looking at on the first slide, this is called the zone of ablation. The zone of ablation has this kind of very clear line called the melt line, or the firn limit, or the snow line. This is down here where we're going to have melting happening faster than accumulation of snow. So there's still going to be snow that falls on here, but it's melting faster than we can accumulate it. So up here, the glacier is getting bigger. Down here, the glacier is getting smaller. Now if you notice down here at the bottom, we also have this big old rock pile. The glacier has carved out rock and really pushed it along. And at the very end, at the terminus of the glacier, we get this kind of bulldozed area full of rocks, and those rocks are very poorly sorted. Some of them are big, some of them are small, some of them are rounded, some of them are very angular and sharp. But that's kind of what you get with glaciers. They're pretty much a mixed bag. So glaciers will go through a couple of different things to create weathering and erosion. I want to remind you guys, weathering is the breaking down of rock into smaller pieces. Erosion is carrying it somewhere else. The main way that we have erosion is by the freeze-thaw. Okay, so we can actually scrape the rock down to bare rock, and if you look in this picture, that's why it's really, really flat in those areas. The glacier has kind of flattened it out, it's scraped it down. But also, when we have ice that is traveling over, some of that ice melts, gets into cracks, it'll refreeze, and it'll actually open the cracks wider, and we talked about that with the freeze-thaw cycle. Plucking is another one. If you get a loose piece at the end, the glacier will just come and kind of push that piece off and break it off. So we're also carrying sediments and rocks, and they will scrape even more and kind of polish the rock. That's called abrasion. One other thing with glaciers, they will carry rocks to new locations. If you guys notice, especially when you're coming in on the road that goes past north, there's a bunch of these big rocks on the cross-country course. Those rocks originally are not from around here. They're not from Ohio. They're up from like Canada. There was a big glacier that we'll talk about later that kind of brought all those rocks down here. But if you look at this, this is a huge polished rock. This was carried to this location by a glacier. This guy standing on it is not me, so don't think that's me. But all right, some things that glaciers form. If you've ever been up to Lake Erie, there's an island that's part of Ohio called Kelly's Island, and it has these world-famous glacial grooves. When there was this glacier going through Ohio called the Laurentide Glacier, it was actually scraping the rock down here, and we got these really cool grooves. If you ever get the chance to go up there, go take a look. In glaciers, we also have these things called moraines, and I'm going to show you some moraines in a map in just a moment, but a moraine is pretty much just a big rock pile. We have them kind of accumulating in the middle of glaciers, but we also have these big old kind of terminal moraines that are like hills full of rocks that the glaciers have just kind of pushed down the mountain. So the erosion here is the glacier is pushing it down the mountain. Remember, weathering is breaking it apart. Erosion is carrying it to a new location. So a couple of other mountain formations, and if you guys look in here, this dark area, these would be some of the rocks that have been carried down the mountain. When they fall off of peaks up here and everything, they accumulate in low areas. This is a moraine as well. It's called a lateral moraine. It's off to the side. We get some other things from these glaciers. We get things like U-shaped valleys. We also get V-shaped valleys. So this one is obviously a U-shaped valley. If in the future this whole glacier melts, then it'll leave this big old depression, U-shaped valley. Sometimes they're V-shaped, and up in these areas it's probably a little bit more V-shaped. We also get these things called aretes, or aretes, depending on who you're talking to. They're these really knife-like peaks on mountains. This is a lot of times what we think of as like the stereotypical mountain. If you're looking at this one, it's got these peaks that kind of run in this long knife-like ridge all the way up here and kind of around here again. That's an arete. Horns are like a pyramid-shaped peak, and you have a horn up here, you have a horn right here. And basically what's happening is we have glaciers going on all sides, and so they're carving it out on different sides. You carve it over here, you carve it over here, you have another glacier carving this way, and so you get these horns. And then a cirque is kind of like at the beginning of where the glacier forms. You get this bowl-shaped depression where it can eventually fill with lake water if the glacier has melted. So sometimes you'll go up on top of a mountain and you'll have this little bowl-shaped lake. That's called a cirque. All right. Here's a aerial picture of a glacier. I believe this one's in Alaska. I have to double check, but up here you can see zone of accumulation. Down here, ablation zone. Very clear distinction between where we're accumulating snow up here and where we're losing snow faster than we accumulate it down here. Now, if you guys look all the way down here, it's pushing rock. You guys can kind of see down here, and this glacier will eventually melt. Glaciers are the kind of the genesis of most of our streams and rivers around the world, so they're very important as far as surface water goes. Here's another glacier. This is a relief map or a topographical map. If you guys take a look at this, you can see the heights. So each of these lines represents the height on the map. If you go down to this one says 11,800, and I believe it's in feet on this. and then this one says 12,000 feet. So this is higher up, this is lower up. So the top of the glacier here is up here. Take a look at what formed at the bottom of the glacier. All that meltwater forms a great big lake. Okay, we have another glacier over here. If you look at this one, it kind of spreads out in two different directions, and it creates a lake over here, creates a lake over here in the meltwater. Okay. All right, this is another good picture of a glacier. If you're looking at the numbers here, down here is the low area. We got 2,700 feet over here. Up here, it's, oh, I gotta get close and look, old man glasses. Oh, I lied. This is actually the higher peak. This is 27. This says 1,900 over here, so this is downhill. Look what forms at the bottom of this glacier. All that meltwater forms kind of like a stream or a river. So you guys can see glaciers are important for our surface water. This thing up here is an ice field. We're going downhill. And again, remember these glaciers usually move very, very slowly. Okay, another map. If you see all these like little bumpy things, these would be the rocks that are carried by the glacier. If you're looking at this one, excuse me, downhill is actually up here, and this is uphill. So this is the top of the mountain, this is down the mountain. Look, you have two different glaciers that actually kind of combine together. These rocks, these are the moraines again. So glaciers will carry lots and lots of rock downhill and large amounts of it. If you look at this map, this is a map of a very famous peak in, I want to say France, but I can't remember. It's in Europe somewhere, but this is called the Matterhorn. Maybe this is in Switzerland. It's not in France, I lied. The Matterhorn is a mountain that has like that pyramid shape to it, but right here we have the Matterhorn peak. This, if you look around here, you can kind of see it's got that, it's almost like a square pyramid. I forget what that is. I forget what you guys call that in math class, but right here is the Matterhorn peak. This line right here is kind of our arete. It shows us all the really, really steep knife-like blade areas. You can see that on both sides of the mountain we have some streams that are forming. So water melts, it goes downhill down here. Melts on this side, it goes downhill over here. Did I scare you? Well, before we get too far, I want to show you something, so check this out. Okay, so why do we care about glaciers? First of all, they form the Great Lakes, which for us is huge because that's like a huge source of fresh water that humans have available to them. They also will flatten the land, they'll kind of compress it, and it makes really good soil because when glaciers are carrying all of that stuff downhill, a lot of that rock will make good soil when it breaks down eventually. So you guys can see this glacier here. It also is going to form a lot of streams, which you can see. They're the source for most rivers, so they're very important. If we have the glaciers up in the Himalayas, they supply water to almost 2/3 of all the people on planet Earth, the people in China, India, Southeast Asia, all those areas. So if those were to melt, lots of people would be very thirsty. Huge wars would probably break out. Also, glaciers, if they end in the ocean, so if like they go down a mountain and then they break off in the ocean, they form icebergs. So icebergs are just pieces of glaciers that have broken off. We all know what happened in the Titanic. So there are also really important historical glaciers for us. A long time ago, during the last ice age in the Pleistocene, we had this huge ice sheet that covered North America, especially up in Canada. That was called the Laurentide Ice Sheet. Covered all of Canada, most of the U.S., and when it melted, it created the Great Lakes, and there was a land bridge in between here and Asia, and all that water that melted basically rose the sea levels enough that people couldn't walk across there anymore. So the leading edge of it is actually right around Ohio, around Lancaster County. If you take a look at this map, some of this red stuff is the deposits from the glacier. So we have all sorts of rock and soil and everything that have kind of come around here and been deposited. We in Ohio, Pickerington is actually just a little bit over here, so we're starting to get a little more hilly. Remember, glaciers will flatten stuff out, and when they melt, they put down a ton of water, which is awesome because we get groundwater. They will also put a ton of soil that they've made, broken down rock, and that's why we have a lot of really good farmland here in Ohio. So, one other thing with the Laurentide Glacier, and this is leading into when we talk about rivers and streams. The Laurentide Glacier, when it melted, created this great humongous lake, which was bigger than the Great Lakes. It was called Lake Agassiz after I want to say a French geologist. I can't remember if he was a geologist or not. But if you look at where Lake Agassiz kind of drains into the different oceans, it has several points where it could have drained. It drained out the St. Lawrence Seaway, which we still have today. So it kind of sent all this water into the Great Lakes and then out the St. Lawrence Seaway. Drained into the Hudson Bay. Drained up here into northern Alaska and Canada and out into the Arctic Ocean. But most importantly, it actually had an area over here where it would drain out, and it created kind of the Mississippi Valley that we have today. So the reason the Mississippi flows where it does now is because Lake Agassiz, which had a huge amount of water, kind of flooded that area, eroded all of this soil out of the way, and allowed for us to have the current pathway that we do today. So remember, glaciers, they are the most destructive of all the erosional forces because they can just basically scrape everything down to bare rock. They're not going to be the most important. Okay, we're going to get to that with rivers and streams, but they are one of the most important, and then they are the strongest of all the erosional forces. So if I was to ask you guys on a test which one is the strongest erosional agent, you would have to tell me glaciers. Okay, glaciers can just scrape everything down to bare rock. They carry tons of rock all over the world. Down big mountains and kilometers and hundreds of kilometers away. So if you have any questions, come talk to me in class, and we'll get set back up, and hope you guys have a great evening. Talk to you later.